Hi everybody, welcome to another video in this quick math section 4.1 divisibility and modular arithmetic. First we define division. If a and b are integers and a not equal to 0, so we're not going to divide by 0, then a divides b if there exists an integer c such that b equal to ac. So we can divide a divide b, meaning that b is divisible by a. When a divides b, we say a is a factor or divisor of b, and that b is a multiple of a. So there are a lot of ways we can say a is a factor of b, or b is a multiple of a. That when a divides b, those are equivalent. The notation a divides b denote that a divides b, so that's the vertical bar. If a divides b, then b divide. Now this is divide, and this means b is divided by a. So that's different. It's an integer. If a does not divide b, we're going to write like that. So next is 3 divided by 7. So we say no. And it's 12 divided by 12. So that 3 divided 12. So that's true. Because I should say 12 divided by 3 is equal to 4. No remainder. So we say 3 divides 12. 3 is a factor of 12, or 12 is a multiple of 3. Here's some properties. A, b, c are integers. Then pretty much if a divides b, a divided by c, then a divides b plus c. And a divided by b, a divided by bc, then a have to be, if a divide b, multiply anything to it, it still divide that product. A divide b, b divided by c, then a divided by c. So that kind of translative properties. Right. So that is how we call things. Divides, factors, divisor, multiple. Those are the things that we need to know. Next, division algorithm. When an integer is divided by a positive integer, there is a quotient and a remainder. And this traditionally called the division algorithm, even though it is the theorem. So we said doesn't matter what a is, and d is a positive integer, so we restrict that to be positive. So it's not going to be 0 either. Of course, it's not going to be negative. Then the q and r are unique, and we can write like this. And because r is the remainder, r is going to be less than the divisor. Right. So we have the terminal divisor, dividend, quotient, and remainder. And so we will write as follows. Dividend equal to the divisor times the quotient plus remainder. Right. Now, what are the quotient and remainder when 101 is divided by 11? Right, we just do the (11) going to that certainly 9 times. That will be 99, and that 2. So we say 101 is equal to 11 times 9 divisor times quotient plus remainder. Right, so 9 is the quotient. and 2 is a remainder. What are the quotients and remainder when negative 11 divided by 3? So we do the same thing. 3, although usually we never rarely use this. Alright, 3 times 3 is 9, but 3 times negative 3 is negative 9. So there are a couple ways to do this. And let's say the remainder we want to be positive, so we want the remainder to be negative. So we have to go over when it's negative. I mean by over, I mean in terms of magnitude, not necessarily that. So if we have 3 times 3 is 3 times negative 3 is negative 9, we're going to miss negative 2 as the remainder. So it's not going to be that. Remainder determined to be positive. So in that case, we need to go over 4, 3 times negative 4, that's negative 12. Now change the sign and add them. So it's 1. So negative 11 is equal to, divided by 3 is equal to negative 4 times plus 1. So quotient remainder. Right. One thing I forgot to write here. We define Q equal to A. I think we say we also define. So there are 2 types of division in very common in calculator. Its first one is called the diff, which is divide, and that will give us the quotient, and the modulo will give us the remainder. So there are 2 types. The diff give us the quotient, and the mod give it the remainder. Right. Yeah. 58 mod 6. So we find the remainder of this. 6 going to 58. 6 times 9 is 54. So the remainder we say 58 mod 6 equal to the remainder 4. 129 and 11 go to 129. That'll be 11 times, be 121. So it's 8. Now this case is the diff. So that gives us the quotient, which is 11. So 1 gives us the quotient, the diff. 1 gives us the remainder, which is the mod. Right. Next we define the modulo arithmetic. Actually we define the congruent. And we say A and B are integers and M is positive integers, then A is congruent to B modulo M. So that not only that, so A is congruent to B modulo M. So that's the whole thing that we define here. If M divides A minus B, right? So that is the way we say that. Now the notation A congruent to B mod M, say that A and B is congruent, so that's the same thing. Or we say A, B mod M is congruent, that M is the modulo. So it's different type of to say the same thing. 2 integers are congruent mod M if and only if they have the same remainder when dividing. So that means when they mod whatever it is, they have the same remainder. If A is not congruent, then we're going to write A not congruent B mod M. Right, so first determine if 17 and 5 is congruent mod 6. So we just take the different, but then we use the first definition here. 17 minus 5 is 12, and 12 divisible by 6, so we say 6 divide 12. So yes, so we say 17 is congruent to 5 mod 6. Notice we have to put in the parentheses here, because the difference, because 6 divide the difference. Next, determine whether 24 and 14 are congruent to 6. Okay, actually there's another way to use that if we say that they have the same remainder. For example, if we take 17 is 2 times 6 plus 5, so remainder is 5, and then 5 is equal to 1. 0 times 6 plus 5, so remainder is 5. So they have the same remainder, therefore they are congruent, mod 6. Right, but the difference is easier. 24 minus 14 is 10, and it is not divisible by 6. So in that case, we will write 24 minus 14, 24 and 14 are not congruent, mod 6. Determine if 115 is congruent to 5, so we just subtract them. And we have 110, and that is divisible by 10. So we're going to say 115 is congruent to 5 mod 10. Now let m be a positive integers. Now we have to this. We have this term. Let m be a positive integers if a and b congruent modulo m. If and if only if there exists an integer k such that a equal to b plus kn. Right? Because it is an if and only if we have to prove two if-then statement. So we assume this is true, prove go to the other, and we assume this is true, prove to going back. So let me write. There's two sides up here because they have a proof is if and only if. So let me just write first one. Number 1. A and B are congruent. Just want to write A and B are congruent mod m. So we assume that is true, then exists k, of course integers, such that a equal to b plus km. Right. Now we assume this is true, need to apply that. Now if this is true, then we can say the difference, that means m divide the difference. Now because if m divide the difference, meaning that exists k such that a minus b equal to mk, and of course from here we can imply that a equal to b plus mk. Right, so one side is good. Now write the converse of this. Now suppose there exists k such that a equal to b plus km. Show that a and b are congruent mod m. So now if a is equal to b plus km, we can say that a minus b is equal to km. And let's just say, right, left hand side here implies that. Now if it is the case, that means m divide A minus B, because it is the multiple, A minus B is the multiple of M, so we write like that. So if it is the case, then by definition A congruent B mod M. Now note we say A congruent with B mod M and A mod M equal to B. Notice that this is mod M, so we can say this is the division. So for example, you can say, for example, let's say 17 congruent to 9 mod 2. But if we take 17 mod 9, 17 divided by 9, that's only one time remainder is equal to 8. So that's different here. Right? 17 divided by 2, the remainder is 1. 9 divided by 2, remainder of 1. Since they have the same remainder, they are congruent. That's what it is. Now this is completely two different things. This is the relation. This is the operation. Right. Now let A and B be integers and M be positive integers. If A congruent B mod M, if and only if mod M is equal to B mod M. A mod M, B mod M. Right. Once again, it's an if and only if, so we have to prove both sides. Now let's say A congruent would be mod M. Right. If that is the case, we need to show that just write then A mod M equal to B. This is equal, that is congruent. Right, I will start with this. Right. Actually, the way we define it to say two integers are congruent mod M if and only if they have the same remainder when divided by M. So this is called the remainder. So by that case we said they have to have the same remainder. So there's this such that it is equal to A mod M, that is the remainder. They have the same remainder, pretty much. We define it. So they are equal, so that's true. Now the other way around, if the remainder are the same, then they are congruent. Right, now if we have this, so let R equal to A mod M equal to B mod M. If there's a remainder like that. Now if there's a remainder, so from the first part we can say A is equal to M times K1 plus R, and B equal to M K2 plus R. Now we need to show that they are congruent. Of course they have the same remainder, then yes, but let's just prove a little bit different. A minus B then is equal to M K1 plus R minus M K2 plus R. R minus R cancel out, we have M K1 minus M K2 So that gives us factor out the m k1 minus k2. So we say m divide a minus b, therefore they're congruent. Mod m. Right. Now we have the theorem. If A congruent to B, mod m and C and D, then we can add side by side and we multiply side by side. So multiply both sides of the valid congruent, preserve that. So we can multiply, add things on both sides and multiply things on both sides. Corollary. If we have A plus B mod m, so that is just like distributive properties. Yeah. So step one thing. Actually, that's good. Move on. Next we call the arithmetic modulo m. Let's see if m be the set of non-negative integers. So this is actually later on where we can see that is a group of non-negative integers less than m. So we go from 0 to m minus 1. All positive. The operation that subscript m define whatever corresponding to that number. And in that case, we define that it's just a plus b modulo m. And then multiply the same way. Right. Let's just do this. What is 7? That. So meaning we're going to add them. And then mod 11. So that could be 16 mod 11. So when we divide them, 16 divided by 11, the remainder is 5. That's what we have. Now how about multiply? That's 63. 63 divided by 11 be 55, so that remainder is 8. Right. Next we have some properties of this arithmetic modulo that closure. So any two element when we add, if we stay in there, associative properties, commutative properties, and then identity element and inverse and distributive. So I'm just gonna list all the properties that associate to the arithmetic modulo m. But we're not gonna cover much after that. So that's all I want to talk about in section 4.1. As always, thank you for watching and see you in another video in discrete math.